In number 7, we cannot have 1 minus the square root of 5 on the bottom of this fraction. That's a radical on the bottom, and that's bad. So we are going to multiply by the conjugate. The conjugate of 1 minus the square root of 5 is 1 plus the square root of 5. It's the same exact expression with the opposite symbol. You can't just multiply the bottom of a fraction, you have to also multiply the top of the fraction. So we're going to multiply both the top and the bottom by the conjugate, 1 plus the square root of 5. On the top, we simply distribute. 1 times 1 is 1. 1 times the square root of 5 is 1 times the square root of 5, or just the square root of 5. On the bottom, we need to double distribute. 1 times 1 is 1. 1 times the square root of 5 is 1 times the square root of 5. Then we distribute the negative square root of 5. Negative square root of 5 times 1 is negative 1 square root of 5. The negative square root of 5 times the positive square root of 5. Anyone know what that is? Negative times positive is going to be negative. The square root of 5 times the square root of 5 would be the negative square root of 25. What's the square root of 25? So it would simply be negative 5. The negative square root of 5 times the positive square root of 5 is negative 5. Now let's look at what we've got under here. What do you notice about these two? They would cancel each other out. So all we have on the bottom is 1 minus 5. 1 minus 5 is negative 4. So here's our answer so far. 1 plus the square root of 5 over negative 4. Now, I would count this answer as correct. But do you think Big Ideas Math is going to count this answer correct? No, they don't like having the negative on the bottom. They want us to move this negative to the top. So we would have negative, and then this stuff would be in parentheses over 4. You're just moving that negative up to the top. And then we can distribute that negative. Our final answer would be negative 1 minus the square root of 5 over 4. That is mathematically the most correct simplified answer. Okay, let's do this whole process again. This time in the denominator, we have 2 minus the square root of 6. First of all, what do you think is the conjugate for 2 minus the square root of 6? 2 plus the square root of 6. If we had started with 2 plus the square root of 6, then we'd be multiplying by 2 minus the square root of 6. So keep the numbers the same, just take that symbol in between and switch it. On the top, we're just going to distribute. 6 times 2 is 12. 6 times the square root of 6 is 6 times the square root of 6. You just write those numbers next to each other. On the bottom, we double distribute. 2 times 2 is 4. 2 times the square root of 6 is 2 times the square root of 6. The nice thing about this multiplication is that it honestly doesn't take a ton of thought because you don't actually have to multiply the things together. You just stick them next to each other. Then we have negative 6, negative square root of 6. We have to distribute negative square root of 6. Negative square root of 6 times 2 is negative 2 square root of 6. I never make my bar long enough. Negative square root of 6 times the square root of 6 will become negative square root of 36, which is negative 6. So this right here is an explanation of where this number came from. Okay, your middle terms. The reason that we multiply by the conjugate is that by multiplying by the conjugate, we're really creating a difference of two squares situation where the middle terms are always going to cancel each other out. You'll have a positive 2 square root of 6 and a negative 2 square root of 6. So all we have left in the denominator is 4 and minus 6. 4 and minus 6 is negative 2. I would take this as a correct answer, but of course, Big Ideas would never take this as a correct answer. There's a couple things going on here. First of all, there's a negative on the bottom, but also look at these whole number pieces. Do 12, 6, and 2 have anything in common? 2. Let's divide everything by negative 2. 12 divided by negative 2, so I'm dividing everything by negative 2. That's my strategy for simplifying this thing. 12 divided by negative 2 is negative 6. 6 divided by negative 2 is negative 3. You can't touch the radical because it's stuck under a radical. And then on the bottom, negative 2 divided by negative 2 is 1. We no longer need the divided by 1, so our final answer is just negative 6 minus 3 times the square root of 6. Okay, do you feel like using your notes, if you had to do a problem like this entirely on your own, you probably could at least muddle your way through it? Okay, we're going to switch gears a little bit, and honestly, we're going to talk about cookies. So, if I had something like 5x minus 3x, what is 5x minus 3x? 2x. X is like cookies. You've got 5 cookies, take away 3 cookies, you have 2 cookies left over. That is really this thing right here. Except instead of x, we have 4 raised to the 3/4. Do you see how 4 to the 3/4 and 4 to the 3/4 are exactly the same? When you're adding and subtracting with rational exponents, the bases and the exponent must be the same. So if you've got 5 cookies minus 3 cookies, and those cookies are exactly the same, it's the same base, it's the same exponent, you can do the 5 minus the 3 to give you 2 of those cookies. So I just think about that thing in parentheses like it's a cookie. 5 cookies minus 3 cookies is 2 cookies. So take a look at number 2. What would our final answer be in number 2? 10 times 3 raised to the 2/3. Now this works for radicals as well. I'm going to do an extra example over here. If I had the, let's say I had 5 times the 3rd root of 2 plus 3 times the 3rd root of 2. Do you see how the 3rd root of 2 is the same as the 3rd root of 2? So 5 plus 3 would give us 8 times the 3rd root of 2. So it's exactly the same when we're dealing with radicals, if the index and the radicand are exactly the same. So what's the problem in number 3? We need to simplify. We need to take this first thing and we need to split it up using our perfects chart. So we want to split this into the 3rd root of something that's on our chart times the 3rd root of something else. And the nice thing about this is this kind of gives us a clue of how we're going to simplify it. This needs to be a 3rd root of 3. So that could actually help you in the simplifying process. If you look at the thirds column, we're looking at numbers smaller than 81. 64 is still too big. I don't think you can do 81 divided by 64 because 64 is more than half of 81. But 27 times 3 is 81. The 3rd root of 27 is 3. So we have 3 times the 3rd root of 3. This thing is minus the 3rd root of 3. What number is in front of this radical? There's a 1 in front of it. If there's no number in front of the radical, there's always a 1 there. So you have 3 cookies. We're going to take away 1 cookie. How many cookies are we going to have left? 2 times the third root of 3. If you can take math and reduce it to cookies, it makes it better, right? Okay, why don't you try number 4 on your own? Simplify the third root of 625 and then see if you can do the subtraction problem on your own. Pause the video, give it a try. Okay, looking in the thirds column at numbers smaller than 625, there are a lot of numbers smaller than 625. 512 is probably not going to work. You could try 343, but as you look through these numbers, is there a number that kind of pops out as probably going to work? 125. Because it's 625, it ends in a 5. You kind of want to look for those other numbers that end in a 5. So this is 125 times 5. Also, this number is going to help you in simplifying the radical because the 2 radicals need to end up matching. So whatever that second radical is, that's going to help you split that up. The third root of 125 is 5. So we have 5 times the third root of 5 minus 1 times the third root of 5. There's a 1 in front of that second term. Now, sometimes there will be numbers in front of that. It won't always be minus 1, but it is in this case. Now we have 5 cookies minus 1 cookie. That gives us 4 cookies. 4 times the third root of 5. Your assignment is Big Ideas Math. It is 5.2 part 3. I think it's only 6 problems.